Has the live started? Let me just check for a moment. Hi, hello everyone. Welcome, a very warm welcome to Deeksha Vedantu YouTube channel. I'm your physics teacher Aditi and we are back with yet again Physics Live, where I'll give you paper out, it's called. So it will include everything you need for your exam, for your class 10th board physics exam. So are you ready? Hi Trev. Hello everyone. How are you all doing? We are going to start this live in just few minutes. Let everyone join. We'll do some questions based on two chapters that are left for today's week. Those are light and human eye. Yesterday we saw these two chapters only, but different kind of questions, most repeated PYQs. Okay, welcome everyone. Welcome to the live session. Hi everyone, can you let me know if audio and video is clear, and can we start the live? Can we start with our questions? Is my video and audio clear? Okay, let's start with first question. Hi Abhimanyu, we are going to start today's live. So today's live again will have two chapters. We'll see light and human eye. Yesterday was PYQs, the most repeated questions, but we know CBSE has changed a little bit of the pattern. There will be CBQs and different kind of questions. So we are coming up with more questions that can help you with the change of pattern. So be ready to solve these, okay? Okay, let's start with the first question. Very easy, kind of. Read it carefully and let me know the answer. Read it carefully first. Read it carefully. A student observed the reflection of light from different types of spherical mirrors, okay, he made the following statements. First, concave mirror can form a magnified and real image of an object. Second, a convex mirror can only form a virtual image. See, take note of all the words that are present in the question. The magnification produced by a concave mirror can be negative. Which of these is true? Let me know the answer in the live chat. Which of these option is true? Yes, you have to tell me the correct statement. Can anybody, you guys are taking a little bit of time, is it hard? Okay, let me just write it. They said first is concave mirror, and they are saying that concave mirror produces a magnified real image, okay? Then convex mirror, in second part, if you can't understand, take out your pen and paper and write everything that is given in the question. A convex mirror can only form virtual image of an object. And then third says the magnification of concave mirror can be negative. Now let me know if these statements are true or not. Can anyone tell me the answer in the live chat? Are these statements true or not? Let me know. C, option C, and Trev is also saying all true. Option C. Okay, correct. Everyone is correct. Option C is the correct answer. We know concave mirror can produce magnified as well as diminished image, but here it says can form. It doesn't say only, so it is true. Convex mirror, however, only forms real, virtual and erect image. Correct. And the third one also says the magnification can be negative. Magnification negative means my image is real and inverted, and concave mirror does produce a real and inverted image, so it is correct. Let's move on to the next question. Okay, next question, second question, read it carefully again. Read it carefully. It says the figure shows a ray of light as it travels from medium A to medium B. Read it carefully, which, the lower one is medium A or the upper one is medium A, and from where the ray is going. Refractive index of the medium B relative to medium A is, we have to find refractive index of medium B with respect to medium A. Correct? That will be NB divided by NA. What will be the answer? Yes, your answer was right, correct. Let me know the answer. Do you guys know the answer of this question? What will be the refractive index of medium B with respect to medium A? If light ray is traveling from medium A to medium B, what will be the answer to this question? A, B, C, D, you have 4 options. Solve it carefully, take your time. See, first you have to focus on solving the questions accurately and correctly. Okay, then we'll focus on speed. First you have to get the answer right. Okay, Abhimanyu is saying A. Okay, one answer is A. Anyone else? What will be the answer? Okay, let's see what can be the answer to this. Now they are saying it is going from medium A to medium B. Now the careful thing, you have to be very careful about one thing, is this normal, this is my normal. Since this hole is medium A, this hole is medium B. So this is normal, this hole is my normal. So sine I and or angle of incidence and angle of refraction should be taken very carefully. This one or this one, this one or this one, correct? So we take the angle with the normal. So this is my I, and then again with the normal. So this is my R, correct? Now solve it carefully. Now we know the formula will be NA into sine I equals to NB into sine R. Now NB divided by NA is what we have to find. So this will be sine I is what? 60 degree. Okay, and sine R will be what? This is 45, so there will be no confusion. Sine 45, and this will be root 3 by 2 divided by 1 by root 2, which will come out to be root 3 by root 2, and that was A. So who was correct? Abhimanyu was correct. Really great. So proud of you. Understood? It's fine, Triv. Understood the question? Can we move to the next one? So be very careful. This is exactly why I got this question for you guys, because there are so many angles which are given. So be careful. Don't be in such a hurry so that you will make any mistake. Okay? Okay. Next question. Again, carefully, easy question. The above image shows the formation of image shows the formation of an image with an optical instrument. Which type of lens is used in the above diagram? This is very easy. They are given the lens. Which kind of lens is used in this diagram? Can you let me know? Can you let me know in the live chat which lens is being used in this diagram? See the diagram carefully. Parth is saying A. A for what? Okay, for the previous answer. Yes, that's correct. Root 3 by root 2 was the correct answer. See this diagram carefully and let me know what lens is being used in this image. Convex, Trev is saying. Anyone else? Okay, So it is definitely okay. This we won't take much time on this. This is a convex lens. We clearly know, just by looking at the lens, we know this is a convex lens. Second part, what type of image is being formed in above case? What kind of image is being formed? This is my object and this is my image. Let me know what kind of image is being formed. Convex. Parth is saying convex. Very good. Now let me know what kind of image is being formed in this particular case. There we studied, right? There the image can be real, it can be virtual, it can be inverted, it can be erect, it can be same size, it can be diminished or magnified. Let me know. Malika is also saying convex lens. Very good. Parth is saying real and inverted. Okay. Everyone is correct. Malika is also saying real and inverted. You guys are correct. So we can clearly see that this image is real, it's inverted, correct? So we haven't studied anything which is virtual and inverted. So the image is real and inverted, correct? Okay. Now third part, you guys are doing really great. What is the image distance from the lens? Okay, this is the most easiest part of this. What is the image distance from the lens? Let me know. Real and inverted image, ma'am. Correct, Malika. You are correct. Now let me know what is the distance of image. Let me just move this on this side. Okay. Let me know what kind of image is being. 40 centimeter. Trev is saying. Parth is also saying 40 centimeter. Just a minute. Okay, you guys are correct. Since the object, just a minute. Yeah, sorry guys. Yeah. So the image is, since my object is placed at 2f1, so the image will also be made at 2f2 from the same distance from the lens. Okay, correct. Okay, let's move on to the next question, which says, read the question carefully. Let me know the answer. Read the question carefully first. Don't do any silly mistakes. Read the question very carefully. So the question says, during a laboratory experiment, a student observes that the path of light through a rectangular glass slab is bent twice. Rectangular glass slab. It is being bent twice. So choose a correct option that describes this phenomena. I'm gonna write physics test for 40 marks in my school for 50 marks just to get. So I hope your video helped me a lot. Yes, it will definitely help you, because we are bringing questions and questions are being asked in your exams, right? So you don't have to worry. Go through, there are recorded videos of lives as well. They are all filled with multiple questions. Just practice those and you will be just fine for your exam. Okay, let me know the answer of this question. Parth is saying A. Parth is saying A. Light undergoes two refractions, at the entry surface and at the exit surface. Anyone else who wants to challenge Parth? Abhimanyu is also saying A. Okay, you guys are correct. You guys are doing really great, yaar. Your concepts are very clear. Let me tell you, these questions, you need strong concepts for these questions and you're doing really great. I'm impressed. Okay, next question. Fifth question, read it carefully. What it says, a student is studying about magnification produced by spherical mirrors and makes the following statements. So he says the magnification produced by a convex mirror is what? Positive, and it's less than 1. If you find problem in remembering things or questioning, just write it down and it will be very clear. Okay, the magnification produced by a concave. Now concave mirror can be positive, can be negative, or it can be 1. Then third, he says the magnification of -2. Magnification of -2 means the image is real, it's inverted, and it's twice the size of object. Let me know if these three are true. Let me know if these three statements are true or not. Take your time, it's fine. If you find any difficulty, just write these down on your pen, on your paper with your pen. Let me know the answer in the chat. Abhimanyu is saying C. Others, what do you think? Is Abhimanyu correct or not? Are these three statements correct or not? Okay, Trev is also saying yes, ma'am. Okay, so Abhimanyu is correct. All three are true. Convex can produce, convex mirror always produces virtual and erect image. So magnification is positive, and it always forms diminished image. So magnification is always less than 1. Concave mirror can have positive magnification for the sixth case, the virtual one. It always has negative for real and inverted, and if we place my object at center of curvature, then the size of image is same. So magnification can be 1. And the third is -2. So minus means real and inverted, and 2 definitely means twice the size of object. Correct? Okay, Parth also said C. Okay, let's move on to the next question. Carefully, read it carefully. A spherical mirror has a radius of curvature of 20 centimeter, which is below in the diagram. Find its focal length. This is very easy. Then identify the type of mirror that always forms diminished, erect, and okay. First, answer me the first part. What is the focal length? Okay, let's not waste time on this. We know focal length is half of radius, so it will be just 10 centimeter. Now answer me the second part. Second part says identify the type of mirror that always forms diminished, erect, and virtual image. It says the keyword is always. What kind of mirror always forms virtual and erect image? Parth is saying convex. Others, what are you saying? Parth also said 10. Very good. What? Be convex mirror. Trev is also saying convex mirror. Okay, you two are correct. Very good. So the mirror that always forms virtual, erect, and diminished image is convex mirror. Correct. Then third part. Is there a third part? Yes. State one use of this mirror. Can you let me know where this convex mirror is being used? Dentist used to see cavities. Wasn't that concave mirror? So that we can see the zoomed version. Let me know. That was concave mirror. Because convex mirror always produces diminished image, right? So why will a dentist want to see your small teeth even smaller? Convex mirror we use for rear view, okay, for yes, side mirrors. For convex mirror, I have also made a short for you guys explaining the convex mirror, how it is, why it is used for rear view images. Okay, let's move on to the next question. Okay, this is a good question. Give it a thought, give it a little bit of thought, and let me know the answer. It says one portion of a convex lens. This portion of a convex lens is covered. Will the lens produce a complete image of the object? Will this lens produce a complete image of the object or not? It's fine, it's fine. Let me know the answer. My lens is covered. Okay, now will this form, if I cover this lens like this, oh, we have exam. If I cover my lens like this, will the lens still make the full image of the object? Oh, I can't see anything. No effect image will form full. cat lover is saying, no, there will be no effect on image, full image will be formed. Dev is also saying, yes ma'am, it will. Okay, form complete image. Correct. Everyone, even if my lens is covered with half or a part of my lens is covered, it will still make full image. Why? Because all the rays from each part of the object, this is my object, okay, let's say a person, and this is a lens. Even if I cover half of this part, the ray from his foot is also hitting this point of the lens, from head is also hitting that part of the lens which is not covered, correct? So a lens will form the full image, but there will be a slight difference on the characteristics of the image. Let me know what those can be. Will the image formed, okay, we know a full image will be formed, but will the image be as bright as it will be if lens was not covered? Let me know. If I don't cover my lens, will the same image be formed with the same brightness or same clarity? Let me know in the chat. What do you think? There are so many of you guys in the chat. Let me know what is your answer. It won't. Okay, Trev is saying that it won't be formed with full, what do you say, brightness. Others, so can I think that all of you others are saying that it will form with complete brightness? Okay, so this is correct. Complete image, Parth is saying, but blur. This is correct. All of you, all of you are doing really great. The number of rays that will be decreased, hence here diminished image. Correct. So when you cover a part of the lens, since it's a what? It's a convex lens, so you can write that yes, the image will be virtual, it will be erect, it will be diminished, definitely, but the brightness or clarity of image will be less, since less rays are passing through this lens. Some of the rays are getting absorbed by that covered part, but other rays are still passing, but instead of going 3-4 rays, just one ray is going, so brightness and clarity of that image will be less. Okay, let's move on to the next question. Okay, very easy. Let me know in the chat, what do you think? It says the refractive index of water is 4/3 and for glass it's 3/2. So refractive index of water is what? 4/3, and refractive index of glass is given as 3/2 with respect to air. What is the refractive index of glass with respect to air? So we need to find glass with respect to, water. What will be the refractive index of glass with respect to water? Let me know in the live chat. What will be your answer? Waiting, I'm waiting for your answer. The refractive index of water is given. The refractive index of glass is given, both with respect to air. Now I want to find the refractive index of glass with respect to water. Trev is saying 2. Okay, let's see. Any other answer? Is it the other way around? You tell me. You guys are here to answer. You tell me what will be the correct answer. Will it be 2? Other people? Will it be 2? What do you guys think? Let me know. I don't recall, ma'am. Please, आप भी बता दो. I will tell you. Okay. Shatadru. I'm so sorry if I'm saying your name wrong. Thanks, ma'am. Thanks for what, beta? Okay, let's do the question. They are saying we need to find refractive index of glass with respect to water. So the formula for this will simply be refractive of index of glass with respect to refractive index of water. Correct? So refractive index of glass is what? 3 divided by 2. Refractive index of water will be what? 4 divided by 3. Correct? If I just solve it, this will be what? It will be 9 by 8. Won't it be? 0.12. Okay, Parth, I have given you the options. Let me know which one out of these is correct. If there is just numerical, you can write 0.12, that's good. But if you're given options, right, you just have to choose. So A will be 9 by 8 will just be the correct answer. Okay? Correct? Moving on. Next question. Okay. State 2 characteristics of the image formed in case of mirror used by barbers. First tell me what kind of mirror is used by barber? Concave or convex mirror? Your barber, when you go see a barber, do you see a magnified image or do you see a smaller image? Parth is saying A. Correct Parth. A was the answer. Now let me know the answer. State 2 characteristics. Just let me know what kind of image, what kind of mirror do barbers use on their shop. Trev is saying plain. Okay, I'm asking between concave and convex. So usually barbers use, okay, Parth is correct. Very good, beta. Barbers when we go to salon or something, we use concave mirrors so that we can see a magnified image of our face or our makeup or your beard. Correct? So concave mirror is used. 2 characteristics can be just, it will be the main characteristics why they use it in a barber is because it forms a magnified image. So you can closely see what they have done to your face or your hairs or something. Okay, so first it's magnified and it will be virtual and direct, since the image will be formed behind the mirror. Because why? Because we place it really close to our face, so the object is between focus and pole. I'm really very nice, please. Okay, it's fine. You just follow our live sessions. We are doing lots of questions on all the chapters. Hi ma'am, please ma'am. Okay, Lakshit Sharma. Hi Lakshit Sharma. Okay, let's move on to the next part. For a convex mirror, the focal length is given as minus 30 centimeter. Image distance is given as minus 50 centimeter. Find the image distance. You have to find the distance of image. It's very easy question. I've got you a bit easy questions today, because not easy I will say, conceptually hard, but a little less numericals, because we have covered the numericals yesterday, right? We have covered really hard numericals yesterday. You can go check that live as well. But since CBSE is giving a lots of competency based questions, so we cannot forget the conceptual questions, right? They will come in the form of these MCQs, correct? Okay, answer me. What will be the image distance? What will be the V in this case? Can anyone let me know? Can anyone tell me the answer? What will be? Okay. Okay, thank you, Lakshit Sharma. Let me know the answer first. Then only it will prove that I explained you very well. If you answer, that will only, what do you say? Let me know if I explained it well or not, right? 300. Lakshit is saying 300. Is that correct? Everyone else. Is Lakshit correct? Is 300 the answer for this question? Ma'am, formula, how do I remember? You just see, the formula is very easy. Let me just explain to you guys. So focal length was given as minus 30 centimeter and my object distance is given as minus 50 centimeter. So for mirrors 1 by f equals to 1 by v plus 1 by u is the correct answer. Now see carefully if this is given as mirror or lens, because lens formula is different, mirror formula is different. So be very careful. So you can just use this formula. 1 by v we need to find, plus this is minus 1 by 50, this is minus 1 by 30. If I just solve this, 1 by v will be minus 1 by 30 plus 1 by 50. Correct? Just take the LCM and this calculation is even very easy. Minus 5 plus 3. So 1 by v will be minus 2 by 150. So v will be minus 75 centimeter. Lakshit, is it correct now? Now Lakshit is saying 80. Let me know if you understood it now or not. Is this correct? Can we move to the next question? Correct? Let's move to the next question. Minus 75, very good. Trev. Okay, next question. Read it carefully. There are lots of questions for, I guess, refractive index today. Okay, when light ray goes from one transparent medium to another transparent medium, it suffers a change in direction. See, again, a very conceptually rich question for you guys. Okay, so it goes from one medium to another, it suffers a change in direction. We know that light ray bends towards normal, correct? Into second medium. Which one of the three parameters, frequency, length and velocity of this light ray changes? This light ray has velocity, it has frequency and it has wavelength. Which of this parameter changes? Trev is saying velocity, Lakshit is saying trying. Okay, it's fine. Just keep practicing. Attend this live every day. We are coming for you guys every day on live. Attend these sessions. They are like, we have done 20. I have only in this week only I have gotten you 80 questions for you guys, and we have gone live previously live as well. Velocity of light, Parth is also saying velocity of light. Not wavelength and frequency both remain same. Let me know, does the wavelength and frequency both remain same? You are saying no, when denser medium to rarer medium the light bends away from normal. Yes, it is going from where? In the light one transparent. Yeah, that is correct. When it goes from rarer to denser, it bends towards the normal. From denser to rarer, away from the normal. Let me know, I asked you a question. The wavelength and frequency, you are saying that it remains the same. Only the velocity changes. Am I correct? You are saying this, right? Wavelength change. Parth is saying wavelength also changes. So why didn't you write it previously? You just wrote velocity. All parameter changes, Trev is saying. Okay, so when light goes from one medium to another, what happens is all parameter does not change. The frequency of light, if one light ray is coming, it won't split into two, right? The frequency depends on the source. If I'm giving the light with the help of a flashlight or with a laser, the frequency depends on the source. So my velocity definitely changes. We know that, right? Velocity definitely changes because this is the formula for velocity. This is how refractive index and velocity is connected, right? So if refractive index changes, velocity also changes, correct? True. Now velocity changes and frequency depends on the source. So wavelength also changes. Frequency remains same, velocity and wavelength of light both changes. Okay, correct. Motion chapter. Bacha, this is class for 10th. In 10th CBSE, we just have 4 chapters, right? Light, human eye, electricity and magnetic effects of electric current. So we are preparing here for boards. In boards there is no motion chapter in physics. Okay? Okay, second part, it says a ray of light enters into glass from air. Does it bend towards normal or away? This is just a very easy answer. Lakshit is also saying wavelength, velocity. Correct Lakshit. Let me know. Okay, again, I won't waste time on this. Of course, we all know that glass is definitely denser than air. So if light enters into glass from air. So if light is going from air, this is air and this is glass. So when it enters from air into the glass, it will bend towards the normal. Correct? Yes, towards the normal path. It's correct. Very good. Okay, third point says light enters from air to glass having refractive index as 1.5. From air to glass, light has a refractive index of 1.5. Correct? What is the speed of light in the glass? The speed of light in the glass we need to find. If speed of light in air is given as 3 into 10 raised to power 8 meter per second. Can you tell me the answer? Ma'am, आप 9th का पेपर पढ़ना please. Okay, we'll see actually Lakshit. Right now we are focused so much on boards. We'll help you in some way or the other, okay? It's fine. You are also going to be in class 10th next year. So be ready. We'll train you like this next year that you will, even near the boards, you will be unstoppable. Okay. Dheeraj is saying pre-board ho gaya ma'am. Okay. Actually there are lots of schools in which pre-boards are still going on. Okay, and if your pre-board is done, there might be some mistakes that you have done, or if you are a topper, you need consistent efforts, right? So join this life, stay in this life, so that the pre-boards that gave you some anxiety or some questions that you couldn't solve, that will be covered here. Okay, Lakshit is saying yes ma'am. Okay, Trev is saying the answer. Okay, let me know the answer in chat, guys. Okay, let's solve this. So the refractive index of glass with air is given as 1.5. Velocity of light in air is given as 3 into 10 raised to power 8. I just wrote the formula for you guys. So this will be what? Refractive index of glass with respect to air, and this will be velocity of in air with velocity in glass. So this is given as 1.5. Okay, this is given as 3 into 10 raised to power 8, and this we need to find. So we can just, if we multiply, this will be 3 into 10 raised to power 8 divided by 1.5, that will be 2. So velocity of light in glass will be 2 into 10 raised to power 8 meters per second. Units are very important. Lakshit is saying, ma'am, मेरे school का भी pre-board हो गया. Okay. How are you guys getting the answer 4.5? Did I do something wrong? This is correct. How are you getting 4.5? The velocity is inversely proportional to refractive index, right? And I wrote everything, guys. Come on. This refractive index of glass with respect to air will be refractive index of glass with respect to refractive index of air, and this will be VA divided by VG, right? And this hole is 1.5 and air is 3 into 10 raised to power 8 and divided by this is velocity of light in glass. C. Okay, Parth has pre-board for 8 December. See, I told you. Now, you also stay and study because you still have boards. Okay. Moving on. Next question. Everyone got it? Okay. Before that, join our WhatsApp channel. You will get all the notifications. A big thing is coming for you guys for your pre-boards. It will be for free. I'll give you that. And it will be very, very useful. It will make you, I will make you score 95 plus in your physics exam in your class 10 board. So go follow this channel and like this video first. I'm standing here, like this video first, then we'll move on to the next chapter. And mind you, Human High has gotten some amazing questions from Human High for you. Okay, it's fine guys. Even if your calculation is wrong, I want you to do all your mistakes in this live session. Okay, that's why this is very important. Go like this video first. Now I want you to do all your mistakes in this live session so that there are no mistake left for you to do in your boards. Okay, I won't let you do any mistake in your boards. So stay here, do all the mistakes. All the mistakes that you have in yourself, take it out in this live session. No one is going to judge you. Okay, we are here to teach you. Okay, enough of Gyan. Let's move on to the first question of Human Eye chapter. A person wears spectacles of power minus 2.5 diopter. Write the given first. Name the defect of vision he is suffering from. What is the defect of vision that this guy is suffering from? This Chashmish guy? Okay, don't call anyone that. Yes, ma'am. Okay. Which kind of defect is this guy suffering from? Let me know. Let me know the answer. Myopia. Are you giving the answer or asking me? Lakshit is saying kal milte hain. Bye. Or maybe you can stay. It's not a physical class. I can't make you stay. So if you want to just cross the video, you can. Okay. What is the answer? Which kind of defect is this guy suffering from? Trev is saying myopia. Anyone else who wants to challenge Trev? Is he correct? He or she? Correct or not? Both. Both. He is suffering from both. Why? Trev is saying both. Okay. So, how to tackle this question? See the thinking, see the approach very carefully. What it is given, when power is given, always check the sign of power first. The sign is what? Sign is negative. Negative. That means if power is negative, focal length is also negative. Correct? And which kind of lens has negative focal length? Which kind of, I'm not sure, but still giving answer. Okay. Which kind of lens is used? Which kind of lens has negative focal length? Lens, concave lens. Concave lens as well as mirror, both has negative focal length. Correct? True. Now, if I'm using concave lens to clear my defect, then what kind of defect is that? In which defect you use corrective lens as concave lens? Myopia or hypermetropia? What kind of lens or what kind of defect is corrected by using concave lens? Now Trev is saying hypermetropia. Stick to one thing. Okay, You're just giving answer. One of this is true, definitely. Okay, so concave lens is used to correct what? It is used to correct myopia. Myopia is what? You can see near objects clearly, but far ones are blurry. So we use concave lens to correct this defect. Now that's asking, draw the ray diagram for the defective eye and its correction using a suitable lens. So I'll just draw this for you guys. Just let me know one thing in the live chat. The image is not being formed on the retina, correct? But where it is getting formed? In front of the retina or behind the retina in case of myopia? In case of myopia, does my image is getting formed in front of the lens or behind the lens? I am very good at drawing and I just, okay. I was right at the starting. It's okay. Let me know, the image is formed in front of the retina or behind the retina in case of myopia. If you guys are thinking, let me know you're thinking, because you're just sitting there with your pen and paper not replying in the live chat. Okay. So in case of myopia, these rays are coming parallel to the lens, correct? And instead of being formed on the retina, they are converging in front of the retina, and that's why the image looks blurry. The image is getting, it's making, this is now the focus of the lens. So image is being formed in front of the retina and not on the retina. It should be formed on the retina, and that's why it's blurry. This is the defective eye. Now correction. For correction, we used what? Concave lens. Correct? We use concave lens. Now, how will you draw this? Very carefully. Draw the eye, and this is my retina. Now, we use what? Concave lens. Now, all the rays that were coming parallel, instead of directly hitting the lens parallelly, they diverge a little bit. But because what the concave lens does, it diverges the light rays. They'll go a little out like this. Let me make this bit clearly. This is my concave lens, and maybe make this a little bigger. This is my eye lens. What will it do? It will diverge the light rays outwards. Diverge the light rays outwards, and then this will get focused onto the retina and we'll see a clear image. So this lens, what this lens is doing, when the light rays are hitting this lens, it diverges those light rays, and then my eye lens converges them directly on the retina. Okay, in front of the retina. Correct, Ray. Very good. Okay, let's move on to the next question. Are these two diagrams clear? Hi, Vivek. Hi, hello, how are you? We are doing the questions right now for human eye, okay? Now, let's see the second question. Study the diagram below and answer the following questions. Name the defect of vision depicted in this diagram. What is the defect? What is the defect of vision that you can see in this particular diagram? Numericals, learn with Sudarshan. Yes. Hi everyone. This is human eye, bacha. We on Monday and Tuesday, I think, we did electricity and magnetic effects of current. You can go and watch those two. There are 2 lives. We did 40 questions in them. Now we are covering light and human eye today. Okay. Everyone is saying hypermetropia. That's great. Numericals are coming. Just wait. I'm gonna come back. My class was proposed. Okay. So definitely we can see the image is not being formed on the retina, it is formed behind the retina. So this is, the defect is what? It is hypermetropia. In case of myopia, in the last question we just studied, the image will be formed in front of the retina, something like this. Okay. Now the next part, list 2 causes of the above defect. What are the two causes of above defect? Sudarshan is saying shortening of eyeball, and correct, shortening of eyeball is correct. Shortening of eyeball. If my image is being made behind the retina, so of course either my eyeball has gotten shortened or increased focal length of the eye lens. Correct. Sudarshan is correct. Aryan is saying shortening of eyeball and cornea being too flat. Cornea, don't write cornea. Eye lens is too thin or too flat, you can write. Piyush is saying repeat. Yes, focal length बढ़ जाती है. Correct. So we are doing this question. It says name the defect of vision. So the image is being formed behind the retina, and in case of behind the retina, we know it's hypermetropia. Why it happens? Like, use some logic. If the image, the retina should be here, right, or the image should be here, so what can happen? Either my eye lens got thin, okay, it got stretched, it got flat, that's why its focal length increased. So focal length of eye lens got increased. Eye lens increases, or if my screen moved towards the eye lens, right, focal length is same, but my eyeball got shortened. Correct? Lens is thin as focal length is increasing. Correct. Increased focal length. Every one of you are correct. Really good. Okay. Draw the ray diagram for the correction of the above defect using an appropriate lens. Let's make this diagram. I know you can't make the diagram in the live chat. Okay. This is an eye. Don't judge my drawing. But you have to make proper ones. Okay, I'll make again. This is an eye. Correct. Now, this is an eye lens. Now, rays, this is, let's say, my near point. Okay. This is my near point, and when rays are coming, they are not getting diverged on the retina, but behind the retina. Correct. This is the defect we are talking about. Now, what we do to correct this is we use what kind of lens? What kind of lens is being used in this case to correct hypermyopia? Concave or convex? Good drawing, ma'am. Thank you, Sudarshan. Thank you. If it was a joke, then also thank you. Okay. What kind of lens do we use to correct hypermetropia? Concave lens or convex lens? What kind of convex? Vivek is saying, Mishra ji is saying convex lens. I was getting a break. Okay, thank you, Trev. Everyone is saying convex lens. That is true. How will we make it? This is my convex lens. Correct? Now, if rays are coming from a point, something like here, something from here. Let's say it's 25 centimeter. We know my near point is, all of our near point is 25 centimeter. Correct? But the people who have hypermetropia cannot see the objects placed at 25 centimeter. They have to keep it away from them. So, what in case of myopia, it diverged the light rays outwards, but in case of myopia, hypermetropia, it will converge the rays little bit, so that instead of going away from the retina, it will get focused exactly onto the retina. Okay, and this is my image. Correct? Correct, everyone? Vivek, Sudarshan, Parth, everyone correct? Can we move to the next question? Ma'am, what is near point and actual point? That is far point. Okay, so near point of eye is what? 25 centimeter. A normal human eye which does not have any defect can see near till 25 centimeter. If you take the object, okay, if you have an object and you place it at 20 centimeter, you must have noticed if you keep the book just here, the words will be blurry, right? So the near point is 25 centimeter and the far point is infinity. So technically we can't see till infinity clearly, nobody can, but we just say that I can see till the earth gets round, okay? So the far point is infinity. मैम आपके कितने बजे होता है क्लास इस चैप्टर का? लेट मी रीड योर क्वेश्चंस फर्स्ट मैम. हाँ, ओके, सो नियर पॉइंट एंड फार पॉइंट इज डन. इस चैप्टर का वेटेज कितना है? सो इट इज डेफिनेटली लेस दैन इलेक्ट्रिसिटी एंड लाइट, बट स्टिल you have plenty of weightage from this chapter. You will get at least one, definitely one or two, since CBQs are more this time, so you will at least get one or two competency based questions from this chapter, since concepts are very important. One numerical might come based on power, and one ray diagram. These kind of questions can also come. These are all PYQs, so these kind of questions will definitely come. This question, the correction of lenses, what kind of lenses is being used, all this will come. I can write you down. Okay, done. Class कितने बजे होता है? In this week it was at 1 p.m. and 5 p.m. 4 days. 2 days it was 1 p.m. and then 2 days it was 5 p.m. We did questions, PYQs, important questions. From next week we are bringing you lots of CBQs hopefully. So be ready for that. Join the WhatsApp channel. This is why it's important for you to join the WhatsApp channel. You'll know, you'll get all the notifications even before starting the live session. We put it there that in 1 hour you have your live, so that you can get ready. Okay, competency numericals please कराइए. Yeah, I am there will be some numericals, and I have also covered numericals in my last lives. If you want them right now, you can go check them, and or of course after this live. If we moved to 75 centimeter of object, what are you saying, Sudarshan? Okay, coaching hai. Okay, you can watch the recorded lectures, it will be there in the channel. Hi Irfan, what are you asking, Sudarshan? Ma'am, if we move to 75 centimeter of object. Bye Vivek, come back, watch the recording. These questions are very important. Okay, let me know what you are saying, Sudarshan, and we'll move to the next question till then. Okay, third question says a person can read the number plate of a distant bus clearly, but he finds difficulty in reading a book. Okay, so he can see distant bus clearly, but cannot read a book नहीं पढ़ पाता है. Okay, what type of defect of vision is he suffering from? Now can you say what kind of defect is he suffering from? No, Irfan, sorry, Ifra, my bad, Ifra. Ma'am, in hypermetropia, if we move 75 centimeter of object, can you give me the exact question? So you're saying in hypermetropia, if we move the object to 75 centimeter, is that what you are asking? Give me the exact question. Okay, I'll give you the answer right now. Write the exact question. Okay, Ifra, correct? Ifra is saying myopia. Okay, let me know. Think again, Ifra. They are saying can read the number plate of a distant bus clearly. The object that is far away, that person can see far away objects clearly, but not the near ones. The person is suffering from hypermetropia. The type of lens used to correct this defect is convex lens. The cause is because eye lens become thin and reduced length of eyeball. Hi Jevin Sharma, hello. Okay, Sudarshan is giving the answer to hypermetropia. Aryan wrote the answer. Okay, you wrote the answer for this question. Correct everyone. Jevin is also saying hypermetropia. It is hypermetropia. Why? Because the person can see far away objects clearly. Distant objects are clear, but near ones are blurry. Okay, and then which type of defect of vision is he suffering from? Done. Name the type of lens. What is the type of lens we used to correct this? What are you saying? Concave lens, Jevin is saying. I want you to think again. Aryan said convex lens. Sudarshan also said convex lens. Correct. Convex lens is used to correct hypermetropia, like we just saw here. Correct. We used a convex lens. We used a convex lens to correct hypermetropia. For concave lens is used to correct myopia. Hello, Jevin. Hello. It's not concave lens, it's convex lens, Jevin. Okay. It's convex lens, Ifra. Convex lens is, yes. Convex lens is used to correct hypermetropia. Okay. Then the next question, next part is what? Write the cause of this defect. So we already knew, right? We already wrote the cause. Let me just tell you again. Cause, in this case, the image will be formed behind the retina. Correct? The image will be formed behind the retina. So the causes will be shortening of eyeball, or the focal length of eye lens increases. Correct? Okay. Everyone clear? Okay. Can we move to the next question? Myopia, concave lens. Hypermetropia, convex lens. Correct? Okay. Let's move on to the next question. Next question says, assertion reason questions, very important, can be very tricky. Now, assertion says a person with hypermetropia, again hypermetropia cannot see nearby objects clearly. This is definitely correct. But the eyeball is too long or the focal length of the eye lens is too short. Is this correct or not? Okay, here we have the question from Sudarshan. If we placed an object before a hypermetropic eye and next we are keeping the object away from 75 centimeter, what is the difference? Image distance. Okay, so see, this question you can use in first case. They are saying hypermetropic person, right? So for hypermetropic person, he can't see the images at 25 centimeter. So if I place an object at 25 centimeter, he won't be able to see. That's what we have to correct. So object distance for a hypermetropic eye is always taken as 25 centimeter. If we place an object before a hypermetropic eye and next we are keeping the object away from 75 centimeter, and then he is saying the object is now at 75 centimeter, what is the difference in image distance? Okay, can't accurately say the other values as I was. Okay, yeah, that's what I was going to ask you, because this question is incomplete. You are just given two things, you as 25 centimeter and then you as 75 centimeter. You let me know in this live chat only. You let me know in the comments. Tell me the answer, okay? I'll give you the answer in the next live session. I promise you. Okay, I can. Reason is not correct. Okay. Everyone is saying reason is not correct. Tanya is here. Tanya is saying A. Okay. We just saw in the last part that for hypermetropia, shortening of eyeball are the causes and focal length of eye length increases. Now here they are saying the eyeball got long and the focal length of the eye lens is too short. So assertion is correct but reason is not true. So A is true but R is false. Okay. Yes, next time. Okay, you can comment in this live as well. I'll look at your comment. Okay, C, Tanya, correct. Move on. Next question. Okay, this is a different kind of defect question. Read it carefully. Let me know the name of this defect. State two main causes of developing farsightedness as well as nearsightedness. It's actually a tricky question. Okay, you just let me know the whole question in the comment and I will give you the answer, okay? Ifra is saying C. Okay, yes, Ifra, C was the correct answer. Now let me know the answer to this question. Main causes of developing farsightedness as well as nearsightedness. First is myopia. Read the question again. Okay, maybe the question is tricky. State far. Okay, fine. Let me just change the question to say two main causes of developing. Let me give the answer to the question as a person can't see far as well as near objects clearly. Now give me the answer. Near objects clearly. Now give me the answer. Wait. Give me the answer now. Yes, presbyopia. Piyush is saying presbyopia. Yes. The question is actually, what if the two causes of developing farsightedness as well as nearsightedness, the same person is having both farsightedness and nearsightedness. That means he can't see far as well as near objects clearly. So that is presbyopia. Correct? Okay. So the main causes of this is hardening of eye lens. What is it? Hardening of eye lens. And that happens why? Because of weakening of ciliary muscles. Weakening of ciliary muscles. Correct? Ciliary muscles are the muscles which hold my eye lens, right? So those muscles get weakened and they cannot contract or make the eye lens thinner. So we can use bifocal length, not cylindrical lenses. Person can't see as far as well as near objects clearly, so that's presbyopia. Ifra is right. Weakened ciliary muscles. Sudarshan, correct. Okay, correct. Can we move to the next? How can this be corrected? By using bifocal lens. Okay. Sixth question. Just one more question for a defect. Then we'll move to numericals, I guess. Aging. Yes, aging is also an answer. Ciliary muscles gets weak with age. Now, what about old age? Is that factor? Yes. Old age is the biggest factor. Old age is a biggest factor. That's why only like with old age your muscle gets weakened, right? So ciliary muscles also get weakened with old age. Okay, a child is able to read his book comfortably but is unable to read the matter written on the blackboard at a certain distance. What kind of defect does he has? If he can read clearly from his book but can't from, see, why am I giving you so many questions? You might be thinking, right? Same kind of questions again and again. Why? Because they should be engraved in your brain. We did the numericals, we will do the numericals, but these should be engraved in your brain. These can be tricky. You can get confused in these questions. That's why you have to practice again and again and again. Okay? Yes, Ifra also correct. Sudarshan is saying myopia. Okay, Aryan is also saying myopia. Correct. If you can't see distant objects clearly, so blackboard is definitely a certain distance away from us and book is near us. So you can see near objects clearly but not far ones, that is myopia. Name the defect. Correct. Correction of the above mentioned defect using a suitable lens, that is, Tanya is saying concave. Sudarshan is also saying concave. That is correct. So concave lens can be used to correct this defect. Done? Let's move on to the next question. Okay, finally, these are the only two numericals you need for your human eye chapter. Okay, I have one or two more numericals, I guess. Solve this, grab your pen and paper, read it very carefully. Take care of the sign convention. Okay, now the near point, read it carefully. The near point of a person suffering from hypermetropia. What is he suffering from? Hypermetropia. Correct? Hypermetropia. So the near point is what? 75 centimeter. So it is 75 centimeter. Calculate the focal length. We need to calculate the focal length and power of the lens required to enable him to read the newspaper, which is kept at 25 centimeter. Now newspaper is at 25 centimeter. Okay, listen to me carefully. We'll do it step by step. We wrote everything down. Now let me know what will be the value of U and what will be the value of V. Ma'am, I is minus 75, U is minus 75. Why are you giving 75 centimeter answers? Why are you writing 75? Okay. We wrote this. Let me know, write in your live chat what is U equals to 25 or 75, V equals to 25 or 75. Write properly. No, don't just write 25 as 25 and 25 as centimeter just randomly. Near point. Write it in one sentence. U equals to what? 75 or 25? V equals to 75 or 25. Let me know. Let me know. What will be? See, okay. Let's do it very carefully. Stay with me, okay? Let's do it very carefully. Now, there is a person who has hypermetropia. That means he cannot read the newspaper that is kept at 25 centimeter. Okay, the newspaper is kept at 25 centimeter. So my object is at 25 centimeter, correct? The object is at 25 centimeter and we know object is always taken as negative. U is always taken as negative. Then they are saying that the near point, his near point is 75 centimeter. That means the objects which are placed at 75 centimeter away from his eye lens, he can only see those. If the object is at 70, 60, 25, he won't be able to see that. So the corrective lens that I am using should make the image of the object at 25 centimeter. It should make the image at 75 centimeter so that his own eye lens can see the image from its near point. So for eye lens, for corrective eye, not the eye lens, for corrective lens, the image distance is 75 centimeter. Correct? Now there are two ways that you can get to see what will be the sign of, that you can find what will be the sign of this V. Either you can remember hypermetropia. We use convex lens. We use convex lens to correct hypermetropia. Correct? Ma'am, is the focal length 37.5 centimeter? Let's see. Let me calculate, okay? Maybe you are correct. Okay. So, will it be negative or positive? So, we studied this diagram for hypermetropia, right? Where is it? So what will happen? These rays goes back. So the object which is at 25 centimeter, this lens will first make the image at 75 centimeter, and then the rays from this object will go back into my eye lens, which will make the image on retina. Okay, so for my corrective lens, the image distance is on the same side of the object, so it will be negative. For convex lens also, V is negative unless the V is actually positive, but in this case what is happening, it's very near to our eye, so the virtual image is first being formed, so this is negative. Correct? Now can we find the focal length? Just by using 1 by V minus 1 by U. Did you understand why I took U equals to 25 and V equals to minus 75? Yes, Ifra, V is image distance, U is object distance. I was asking, will V be 25 or 75? If it means object distance. Okay, V is minus 75, Sudarshan. Okay, V is minus 75 centimeter and U will be minus 25 centimeter. Correct? Understood, everyone? Now we can just calculate the focal length. Correct? So focal length will be 1 by V is minus 75 minus of U is minus 1 by 25. If you take the LCM, you can take just 75 as the LCM and this will be minus 1 plus 3, that will be 2 by 75. Correct? This is positive and this will be, yes, 37.5 centimeter. Somebody gave the answer as 37.5, right? Aryan, you were correct. Okay, now did you understand that? One more thing I want you to see, I want you to realize why V negative is correct. Because the focal length that we calculated is plus. Correct? So the focal length we calculated it as positive, and we know, we studied that focal length of convex lens is positive. Correct? Correct? Ma'am, how minus 75? Okay, do you know one case where the exceptional one, where the object is between focal length and focus and pole? So in case of metropia, we generally take it as that my object is between pole and focus. So what happens is, first the convex lens that is in my glasses, okay, not my eye lens, the convex lens that is in my glasses, and then there is a lens inside my eye. Okay, this is my corrective lens, this is my corrective lens, okay, and this is my eye lens. So what basically should happen is, first my image is at 25 centimeter, but my eye lens can only see objects which are at 75 centimeter. So what is the job of this lens, this corrective lens? Its job is to make the image of this, the object which is at 25 centimeter, what it will do, we consider that this first makes the image of this object back at 75 centimeter. Okay, now my eye lens can see this image clearly. Now the rays from this image will go into my eye lens and then it will focus the rays onto the retina and I'll see clearly. Okay, did you understand now, Sudarshan? I told you two scenarios. First is, we generally consider in case of hypermetropia, the object is between focal length and pole, focal length and optical center. And in second, what basically should happen, this object which is at 25 centimeter can't be seen by my eye lens. My eye lens can only see objects which are beyond 75 centimeter. So what this lens does, this makes the image of this object first at 75 centimeter, then the rays from this image will go back from in my eye lens. Okay? Okay, understood? Clear? Ifra is saying bye. Bye. Okay. Okay, let's move on to the next question. I want you to stay because only just 1 or 2 questions are left and very important numerical is left. Your all doubts will be clear with that numerical. Okay, this is just a normal question. The twinkling of stars in the night sky is attributed to a phenomena of light. Choose the correct option that explains this phenomena. What is it? Atmospheric reflection, atmospheric refraction, atmospheric scattering, or atmospheric dispersion? Ifra is saying, no, I can't understand. Okay, let me okay, let me explain this again. I will explain this again, just a second. Aryan is saying B, atmospheric refraction of starlight. Okay, you are correct. This is a very simple question. When we know twinkling of stars is happened due to the atmospheric refraction of light. Okay, the last question, let me tell you something. There is an object which is placed here, but my eyes can't see this object. They can only see the object which is here. Okay, so what this glass is doing, what this specs is doing, it is making the image of this object at here first. Okay, then light rays from this image goes into my eye lens, and that makes the image at my retina. Clear now? The image of this object is being made here first, then it goes into my eyes and it is focused on the retina. Abhimanyu is also saying B, you are correct. Okay, let's go to the next question. Okay, this is a very good numerical. Very good numerical. Can you solve this? Abhimanyu, Aryan, Sudarshan, can you guys solve this numerical? HHH said hello. Hello HHH. Okay, they are saying near point of a far-sighted person is 40 centimeter. So near point is 40 centimeter. Again, a really good question. These are the questions that you'll get confused in mostly. Near point is 40 centimeter. He wishes to reduce it to 25 centimeter. So he wants that his near points become 25 centimeter again by using spectacles, obviously. Find the power and nature of the lens used by him. Manish is saying Ram Ram ma'am. Ram Ram Manish. Ram Ram bhai saryane. Okay. Can you tell me the power and nature of the lens used by this person? राम राम भाई सारे ने, आज है हमारे लाइफ का चौथा दिन एंड हम कर रहे हैं 9th क्वेश्चन. लेट मी नो द आंसर इन द लाइव चैट. कैन यू गाइस, ओके, जस्ट टेल मी what will be u and v. Will you be 40 centimeter or 25 centimeter? Let me know. It's a very important numerical. Okay, let me know the answer. Okay, let's study. Let's see how to solve this question. Focus on the approach. Should I wait? Are you guys solving or should I explain the solution? Let me know. Are you guys trying to solve this question or should I give you the solution now? Don't know. Okay. It's fine. It's fine. It's very easy. Just have to read it carefully. Okay. What they are saying that the near point of a far-sighted person is 40 centimeter. So, if my near point is 40 centimeter, that means I can only see objects at 40 centimeter. But I want to reduce it to 25 centimeter. So, what I want basically is that my object is at 25 centimeter. Okay. So yes, the object is at 25 centimeter, but I can't see it. Like without glasses, I can't see this object. I can only see this object at 40 centimeter. But I want to wear the spectacles and correct this. So what will happen that with these glasses, my near point will come back to 25 centimeter. Correct? Till now, correct? So what is happening is my object is at 25 centimeter. Correct? But I can't see it. Object is at 25 centimeter, but I can't see it. Where I can see is at 40 centimeter. So what I want these lenses to do, to make the image of object first at 40 centimeter, so that my eye lens can make the image at retina. So object is at 20 centimeter, my eye lens is making the image at 40 centimeter, and then that image is being made at eye lens. So image distance is 40 centimeter and both are negative, we saw in the last question, and u is minus 25 centimeter. Ma'am, v is minus 40. Correct. Aryan is correct. You understood? This is the trick. After this, it's just calculation and formula. But you need to be very careful with choosing what v and u will be. Okay? This is my object at 25 centimeter and this is my lens. Correct? This is my lens here. Now object is at 25 centimeter. My near point, however, is 40 centimeter. Near point is 40 centimeter. That means if the object is at 25 centimeter, I want this lens to make its image first at 40 centimeter so that my eye lens can make the image of this is retina. So my eye lens, so that from this point my eye lens can clearly see and the image will be on the retina. Correct? Understood? Understood. Thanks. Okay. Samina. Hi. Let me know how to pronounce your name. Okay. Understood? Everyone? Correct? Maza aa raha hai? Are you now understanding the question? Maza aa raha hai to like kar do yaar. Please like this session if you are enjoying, if you are understanding the questions. Okay. After this, it's just calculation. Let's see. U equals to what? Minus 25 centimeter. Minus 25 centimeter. V was what? Minus 40 centimeter. Correct? Okay. You just, what we needed to find the power. So to find the power, I definitely need one focal length. So I can just find the focal length using lens formula. Very easy, ma'am. Correct? 1 by minus 40 and this will be minus 1 by minus 25. Correct? Can you just solve this? Can you solve this calculation? Hi, Karan Kumar. I remember you being here in my life. Hi, Karan. Okay, I've seen this. Yes, and thank you. And thank you for the likes. Okay. You can just solve this. You can take the LCM. Try to do this calculation repeatedly. Okay. Do calculations like this so you can solve the questions easily. This you can take as 200. This will be minus 5 and this will be plus 8. Okay. So this will be 3 by 200, which will be focal length will be 200 divided by 3. Correct? And then power will be just 3 by 200 because focal power is 1 by focal length, right? Okay? Aryan is saying power is 1.5 diopter. Correct. Yes, for that again. Let's just calculate this first. This will be around, focal length will be around what? 66.67. Can I write? But this is in centimeter. Okay, this is in centimeter. For power, we need to convert centimeter into meter first. Do I have another slide? Nope. Okay, so if I convert, so for power, I need 66.67 centimeter. I'll convert this first in meters. That will be 66.6 into 10 raised to power minus 2. Correct? That will be 1000 divided by 6, or you can just write 7 or 6. And yes, this will be 1.5 1.5. So your power will be 1.5 diopter. Correct, Aryan was correct. Very good. So proud of you. Okay, now I want you to learn the calculations. Okay, you probably won't have enough time in your exam. I pray that you do, but if you don't, you need your calculation power. Okay, if you don't have if you don't practice for calculation, it won't be easy to get the marks. And what is important? Diopter is important. Okay, moving on to the last question of this live session, 10th question, which says, with the help of ciliary muscles. Okay, this is also a conceptually strong question, so just stay for a few minutes. Very important. With the help of ciliary muscles, the human eye can change its curvature and thus alter the focal length of its lens. Correct? Then they state the changes that occur in the curvature and focal length of the eye lens while viewing distant object and nearby object. Let me know, ma'am, in magnetic effects of electric current, all diagrams equally important. You can say that, because even to reach till, see, solenoid is very important, but to reach till solenoid, your concept should be strong as a bar magnet, right hand thumb rule, left hand thumb rule, circular coil, all should be very important. You get lots of questions on circular coil, the direction of magnetic field because of circular coil, around the circular coil, inside, outside. Okay, you will get diagrams. You will get diagrams on Fleming left hand rule, where the force is happening. Okay, so if you want, I can tell you that Fleming is important, magnetic solenoid is important, but to study those, to learn those, all previous ones are important for your concepts. Okay, yeah, in paper I can definitely say Fleming is important, magnetic solenoid is important, circular coil is very important, and the basics you should know, north to south, south to north. Because ciliary muscles relax while viewing distant objects. Ma'am, in magnetic, okay, you read that. Because ciliary muscles relax while viewing distant objects, then my eye lens becomes thick or thin. The focal length of my eye lens increases or decreases while viewing distant object. Let me know, does it increase or does it decrease? Ciliary muscles relax, that is correct. Guddu, hello Guddu. So Guddu, tell me, the focal length of your eye lens increases when you see distant objects, or it decreases when you see distant objects? Let me know. Hello. Let me know. Come on, guys. Thin, decreases. Both your answers, thin and decrease. One is, they are counter. If the lens is thin, how will its focal length decrease? The focal length increases for distant objects. Aryan is saying. Aryan, animal lord. Oof. Okay. Let me know. Guddu is saying decrease for distant ones or near ones. Okay, let me tell you the answer. Aryan is correct. Aryan is correct. So for distant objects, when objects are at distance, and this is my eye lens. So what happens is, let me tell you this numerically. Okay, I have this formula 1 by f equals to 1 by v minus 1 by u. Correct? Now my image distance remains same. From eye lens, this is my eyeball. Okay, this is eye lens. This distance, eye lens till retina, it always remains the same. Correct? So this quantity does not change. This quantity is changing. So focal length will change. Very first point, correct? Now for distant objects, my focal length increases. You wrote it right, that ciliary muscles relax while viewing distant objects. And did you delete your okay, it's fine. So what happens is, my ciliary muscles, this is my ciliary muscles and this is the lens, okay? If the ciliary muscles are contract, my lens, if ciliary muscles are pushing it down, it will contract. If my ciliary muscles relax, the lens will become thin. This is a motu lens and this is a patlu lens. Patlu lens is used for distant objects and motu lens is used for near objects, okay? This is a near object and rays are coming so that it can diverge at this point. Now this lens also has to diverge at this point, but these rays are coming in all directions, correct? From here the rays are not getting diverged a lot, so my eye lens can be small and collect all the light rays. But in this case the object is very far away, so eye lens should be a little thinner and a little larger, longer, so that it can collect as many rays and then it can focus it on one point, correct? So ma'am, the exact answer, it is when my object is at very distance, far away, what happens? Ciliary muscles relax, okay? Eye lens curvature, this is curvature, so its curvature decreases. Its curvature, this is increased curvature, this is decreased curvature. So when it relaxes, the curvature decreases. Eye lens becomes thin, and hence focal length increases. You can just remember just by this point that if distance is more, focal length of eye lens is more. If distance is less, object is very near, then my focal length will decrease, correct? More distance, more focal length, less distance, less focal length. What is your question, Karan? Yes, okay, let me just clear this part and you can okay, take the screenshot. You can take the screenshot. What was your question, Karan? The focal length increases for a distant object. Correct, Aryan, you are correct. Then any more questions? Anything left? Explain why a normal eye is not able to see distinctly the object placed closer than 25 centimeter without putting any strain on the eye. So I have a lens in my eye. That lens has a limit. It can extend till here, not more than this, not like this. It can extend till here and it can bend also till here. It cannot bend more than that. So it can only bend till here, and through this bending, because of this bending, the extent of this bending only allows the object till 25 centimeter to appear clearly. Okay, correct? Understood the answer to this particular question? This particular point, my eye lens cannot bend to a certain, after a certain extent, and that is why it is my eyes pain when I read something this close to it. Okay, that is it. We are done with today's session. In this particular week, we did 80 questions of physics. 80. Can you imagine? 80 are a lot. So I need you to follow us along, because I know you want to score good in your class 10th marks, and I guarantee you on this channel we will make you score 95 plus. I have put so many years in physics and you can make use of that. I'll bring you so many questions, and I can guarantee you no question in your paper will come out of, see, we've done 80 questions. 80 questions are a lot, and we are coming with CBQs, a lot of CBQs next week for all the subjects. So go follow this channel, join this WhatsApp channel, so that you get all the notifications when my class is happening, when all the other teachers' class is happening. Guddu is saying please, 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 for what? When you started this live was started at 5 p.m. It's 6:40 now. Oof. It was started at 5 p.m. We are on this channel going live at 1 p.m. and 5 p.m. this week. Next week we'll go live for a little bit longer time. We are bringing you lots of CBQs for all the subjects, because we know CBSE has told us that there will be lots of CBQs. So we need to practice, okay? Okay, so come back next week, come back with more power, more energy. Join this channel, like this session. If you liked the questions, if you want more questions, join this channel and subscribe this channel as well, because we are bringing something very big for you. For your boards, we are here. We will guide you till your boards and will make you score 95 plus. Okay, this is my promise to you. Just be consistent. Okay. Guddu is saying please, please, please. Please what? Or you're just... Okay. Okay. Thank you guys. Bye, bye.